You can read this situation here 2 weeks before the major election, blah, 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 blah. Okay, you can read that on your own. Let's go through the basis. All right. Yeah, sure, let's start with the following. What confidence level do you have? Okay, we did 95% for the other one. Why don't we do confidence level 95%? Okay, if I choose that, then my Z star is 2.576. And again, you can look at the other page and see that that's the number we produced, rounded. But I did mention there's another one. What's the other confidence level that's typically used? The answer is 90%, but actually hardly ever used. Really, the only two confidence levels that we ever use are 95%. Oops, did I say 95%? Let's say, I said 99%, but I wrote down 95%. 99% and 95% are the really, you pick up a journal, you're going to see most likely 95%. If you really want to be certain, then you're going to pick up 99%, but there's a trade-off, as you'll see. So what are we trying to do in this case? Well, what is P? Proportion of those that will vote for candidate candidate A. Okay, so that's success. Success, vote for candidate A. That is success. All right, let's figure this out. Of the 320 people who have participated in the poll, 275 denoted that they will vote for candidate A. So that's P hat in this case. That's my P hat value is 275 over 320. Okay, do I meet the success failure criteria? Success. Well, success was 275, certainly bigger than 10. About the failure condition. Well, let's see. Ooh, it's getting close. So 275. That's 25 plus 20 more. That is 45. So there's 45 failures, but it's okay. They're bigger than 10. So yes. So this means meet CLT, which means that the sampling distribution of P hat is approximately normal in shape. Okay, so I meet that criteria. About a bias thing, 2 weeks before a mayor election, City will host a popular radio station, conducts a poll to see how many people will vote for candidate for mayor, who the host of the radio show supports. Wait a minute. The radio host asks his listeners to go to the radio station's website where they can select the candidate they will vote. Okay. Bias? Do I meet the bias criteria? Like, as in not biased? And the answer is no. The sampling process is biased. Oh, wah wah. So, any calculation here is worthless. All right, so if our, what are we trying to do? Does it even question determine what is? The local political radio host, popular radio station, conducts a poll to see how many people will vote for candidate for a mayor for mayor. Okay. That's the goal of this person. So if that's the case, they're talking about in the general population. So yep, I'm sticking to this. This is biased. It's pretty much worthless. I'm going to go through the process anyway, just to have fun with it. So, but again, the result is going to be no good. So it doesn't really matter how big the sample size is. It's all suspect. I'm so disappointed in this radio host that I'm just going to go through it very quickly. And you can just try and see if you can take this on your own. And again, I'm just going to calculate the margin of error. So go here to GeoGebra and just, not GeoGebra, Desmos, and just type the whole thing in one shot. I'm not even going to go find the standard error. 2.75, 272.576 times square root of fractions, lots of fractions, 275, 320. I should have done this. I'm going to highlight this because I forgot to put another, I should have done this at the beginning. Oh, I blew it. I will do this again. Can I copy it? Nope. Don't do that. All right. Oops, come back. Type this in again. 320. 275 divided by 320. 1 minus I'm going to approximate this now. I don't need this many. So we can see that the margin of error, in this case, is when adding, subtracting 5% of from this point estimate. So what does that give me? As a matter of fact, what is this point estimate? Just for, in my mind, 275, divide this by 320. Okay, so it's, in this case, 85% of the people that came, did this poll were supportive of plus or minus, and then marks the value below. So when I do this, okay, grab these two values. That's not good. Got that all in right. And I'm sure, oh, I see there's an equal sign. That's what's throwing me off. Okay. Okay, that's not what I meant to do. Like the average subtract. Okay, there's better. So I add the one amount. So on one end is 0.90, and this is almost worthless. So I'm just definitely trying to hurry up with this. Anyway, and then notice I need to subtract. So I'm going to just negate the margin of error, and I get the other one. Right here. But we're not 99% sure that the people in the city that are going to vote for candidate A. I don't know. Is this even representative of this host? The listeners of this host? I guess so. It was listeners of the host. So maybe the best we could say is we are 99% confident that between, okay, I'm going to round this 80% to 90% of the host's listeners will vote for candidate A. And I'm hoping that the listeners for that day were a representative sample of all his listeners.